Thank you so much to everyone for coming to my talk today. So I'm going to explore, this actually is more of an exploratory type of topic. As you know, generative AI took the world by surprise since it came out in November of 2022. And the thing is too, with multi-agentic generative like workflows, as some of you are aware, it came out probably like in April-ish of this year. So it's really just a few months and not actually that many examples yet, but I've been kind of closely following it too. But first of all, before I get into it, may I ask you how many of you are already working with generative AI apps in here? Oh, wow, quite a few too. And are you like already looking into multi-agentic flows too? Some of you? Yeah, maybe, yeah, one. And I know it's quite new. So how many of you are doing RAGs, maybe, like a RAG type of app? Oh, okay, so a few too. And then what other thing? Many of you, I believe you are already using ChatGPT as like a consumer, right? You're going to ChatGPT or Claude or all these other models. Okay, so yeah, so a lot of you actually have already done that. So, but still, I have to make the assumption that maybe not everybody already is working, and I'm sure you are experienced developers, but maybe new. How many of you actually are more newer to AI, generative AI, and then you are an experienced, or whether or not you are experienced developers too? How many of you are actually quite new to AI, right? To using, yeah, no worries, because I also have to share is that wherever I've been talking to, I've been a developer advocate for the past 6 years or so, I'm noticing that a lot of places, a lot of developers that are experienced, but to work with AI is still new. And also there are even some, the community that I'm from, kind of primarily from, Java. The Java developers are actually slow to adapting because they also have a strong opinion, thinking that, well, AI isn't going to change anything, so what, nothing new, kind of a way of looking at it. However, I think there's a lot of potential, and that's what I'm in it too. So, okay, well, without further ado, I'm going to start. So this is the agenda. I'll give a quick introduction of myself really quick, and then I still want to go through a couple of basic things first, and just to kind of make sure we're on the same stage. And then I get into, the title of this talk, streaming. So I talk a bit too about data streaming, GenAI, and kind of explore into using those techniques for generative AI. And then the RAG, very quickly, kind of talk about that, and also a bit of a vector search too, vector data store, because that's kind of being tied into a lot of the RAG implementation, and then get into the agents and workflows and multi-agentic side and some sample, actually I should say just some sample suggestions. I have to admit, didn't have a chance to get into a lot of the implementations. It's been kind of not easy to find. And then the challenges of GenAI. So I think that should give us in the next 45 minutes or so of some content. So who is Mary? So I'm really quickly too, as well, already Patrick introduced me, Java champion, all these things. And then I also run to the Chicago Java users group, obviously in Chicago, and that's where I live right now. And then I also run the AI camp too, another meetup that's focusing on AI. But my area too, I started off more as an engineer myself for over 20 years, and then I became advocate for 6 years. A lot too have been into distributed systems. That's really what I'm really interested in, reactive systems, and then getting into streaming, some IoT. I work a bit too with MQTT, and now into real-time AI, machine learning, all those things. So these are just about me, and I'm at this company called Scalability. It's based in the US, in Cincinnati, a smaller city that's 5 hours driving from Chicago, in Ohio, the state of Ohio. So we do kind of what you call like an enterprise type of application, Java, .NET, those DevOps and mobile, but now also expanding into AI. So, okay, so really quickly too, a brief background, right, intro into generative AI. Just kind of really quickly, kind of looking through the timeline, it really, if we kind of look into this generative AI revolution, it really came out of like the early 1900s, not too early, but 30s, 40s, in that time frame, when, essentially too, the father of modern computing, Alan Turing, came out with a paper saying, can machines think? So that really triggered a lot of a lot more research kind of towards that direction, as you can see. So here I won't get into all the details, but if you're interested, I didn't draw this, so I just have this link so you can kind of take a look. All of these are kind of, at the time they didn't think of getting into generative AI. And I also have to say too, essentially too, this whole AI kind of thing. Artificial intelligence is really about automation. If you kind of think about it, it's not really in itself the thing, but it is a tool to enable us and enable our lives to be better. Like it's basically do a lot of tedious type of work. And I don't believe that it will take away our jobs, but actually if we can identify a lot of repetitive type of things, tasks that require us to think a lot of processing, that might be a good candidate for it to do, rather than taking over our lives. So let's really quickly too, AI, machine learning, deep learning, and this is that's kind of like a very high level to kind of describe this, is AI is mimicking the intelligence and behavior patterns of humans and other living entity. And then we get into machine learning. That's where all the traditional machine learning supervised and supervised reinforcement training is. And it's basically we're having the computers learn on its own by looking at the data and train itself. But by itself it's not enough, so that's why we get into deep learning, the neural networks, in which that's where all of the really complex research and development nowadays, LLMs, generative AI, is in that neural network kind of core layer, in which is we're mimicking how our brain's neural network works, right? So kind of like quickly, that's what it is. So fascinating look at the generative AI era. So what is it, right? And why is it so disruptive? First of all, too, as we all know, now, right, we can actually ask the computer to do work using human language. And that's actually one biggest advantage than before. Because before, what do? We have to follow strict rules. If we want to ask the computer to do work, you have to kind of go in and let's say even just a simple program, you have to say what kind of parameters, you have to configure all of these things. But nowadays, done away with that. You can actually just ask it to do things for you. However, if you look at it, then the input has become more fuzzy too, because you can ask without worrying. I mean, from the programmer's perspective, there's no need for us to be worrying so much about what type of data is passed in, all of these things. All of these things will be sorted out by the LLM. So that's, if you think about it, is also a way of reducing us having had to, as developers or technologists, to worry about that level of details and then let the machine, the models to kind of deal with it. Although it's not perfect right now, as we know. So that's what GenAI essentially is, first of all, and then also the content it generates too. If you pay attention to it too, if you think about it, it's more about timeless thing, about writing an essays, writing code, and it's not restricted by the time, as before, as if you kind of compare it with predictive AI, in which it's a bit more about business forecasts, weather forecasts that has a bit of a time to it too. Like business forecast usually is 2 years forecast or 6 months forecast, all of these things, and it also crunched through a lot of data, and then it's also based on a lot of statistical model to kind of generate the results, whereas generative AI is a bit more creative side, right? Writing essays, drawing pictures, and all of these things is a bit more creative on that side. Okay, so now, let's really quickly, I just wanted to point out to this whole generative AI era, and if we kind of go back in time, it's basically, I wanted to point out a couple important, papers and research or products, right? In 2003, there was the feed-forward neural network language model that sort of like kind of showed the hint of the beginning of this GenAI kind of revolution, so to speak. And then 2011, Apple, kind of the first, Siri, iPhone working with Siri is the first natural language processing, assistant that can help with, kind of essentially to dealing with text-to-speech, that type of recognizing natural language processing kind of technology. And then 2013, though, I wanted to point out the Word2Vec. It is an important paper because it forms the basis for doing vector database similarity searches too. So that's actually came out also from Google, 2013. And then 2017 was also another major paper called the Transformer. So if you have been following all of the machine learning, all these research, that's where the punchline, that key that says attention is all you need. And that's where that that punchline came from, is from that paper, the Transformer, also came out of Google too. So that's kind of like building up to this generative AI era. So just kind of really quickly look at all of the generative models just to kind of make sure we're on the same page. As we all know, right, there, ChatGPT 3.5 that came out in November, less than 2 years, barely 2 years ago, and then GPT 4.0, and now there's also the GPT 4.0 and the 4.0 mini, all of these things, and came from OpenAI. And as we know too, those are primarily, initially started on more text-to-text, but now we're seeing more of these multimodality support, for example, like Gemini, and also, actually, this, I actually have a bit of an older slide, so, apologize, but actually BERT, I point out to BERT is a pre-GenAI LLM kind of model, although it's not strictly an LLM because it doesn't have the generative capability, truly speaking. BERT is more a transformer. So if you want to strictly label that, and then there's Mistral. Then there's also like Stable Diffusion came out with the first text-to-image, image-to-text model that came out from Stability AI, Stable Diffusion that has inspired DALL-E, Midjourney. And then Codex is more of the code, text-to-code, code generation. That's what a GitHub Copilot is based off of. And then Anthropic Claude. Anthropic is kind of a branch off of OpenAI. Cohere, Mistral, all of these, Llama, of course, Llama 2, Llama 3, these are open source models. And so these are like a handful of these models. There are plenty of other models as well, but those are kind of the major ones. Likewise, there are generative AI apps too, ChatGPT that being the most famous of it all. And I point out to Gemini is also itself a platform that works with Google Vertex AI. Previously was called BART. And then there are other ones too. These I just gave a small handful, but without saying, everybody knows there are plenty of Gen AI apps out there. Okay, just one thing to point out is that the Gen AI to this whole revolution too is that one aspect of it is to deal with the different modes, right, modal. And so we're talking about the 6 major modes, the text, image, code, audio, video, and 3D. So these are the different modes, and so the value would be to try to do conversion between text to image, image to text, or to video. As we know, for example, OpenAI came out just a few months ago with the text to video, video to text with Sora model. And then, of course, Gemini is also a multimodal, kind of model we can use, and all of these too. So they are kind of one kind of major research area in this space too that I wanted to point out. Just one thing to point out is that LLM has kind of limitations. There's no memory in it, and also it can't do, by itself, right? If you use just a ChatGPT interface to kind of query it, and it doesn't remember, unless you write some code, for example, like using LangChain, something, right? That's why it's called chain, because you try to build a context in your query, right, to kind of query the LLM. But otherwise, too, it's a one-shot type of prompting, asking it some questions. It doesn't remember things, between different asks. And also the results are probabilistic. And also you cannot add any attribute to the answers too. It's also, not to even mention, is that the cost is very high. There's been actually studies too that is showing just doing a regular Google search is actually, if you do the same kind of search, if you use regular search, Google search, it's actually less expensive, like 10 times less expensive than if you have to do a ChatGPT type of search, because of the amount of energy it needs to process in the data center, things that we usually don't think about, but if you kind of dig deep inside, it's actually costs a lot of money, not to even mention training the LLM is very expensive. So, and then in order to make it more ready for prime time, we have to think about scalability, security, how about complex tasks and workflows, and that's what we're exploring into is this multi-agentic approach for doing workflow type of situation, all of these things. So just these things that's just to keep in mind. This is just a diagram to kind of illustrate, but still with the current like GPT, ChatGPT, and LLMs, all of these revolution, it is already lowering the barrier to AI, because if you think about it, right, it used to be before the LLM, this ChatGPT revolution, if we want to use AI, usually, let's say Watson platform, some other platform, right, IBM, for example, then you need kind of a lot of setup, and also you have to maybe write your own client and cost a lot of money just to use AI before. But now with the ChatGPT, you can actually go to chatgpt.com and Claude and Llama 3, and also now, for example, like LM Studio, you can actually use that to download locally into your space to do querying. So it's a lot more, accessible, right, kind of for all of us to use. So still, this is, in humankind, this whole generative AI revolution is making a lot of progress for humankind. So, okay. Then let me also understand a bit of the players in the Gen AI era too. So GPT, I think actually this might be a bit of a repeat, just wanted to kind of say it again. GPT, it stands for Generative Pre-trained Transformer, and essentially it takes simple prompts, and then it takes that as natural human language format and as input, and then it does pattern matching, essentially the search, right, to kind of return you the response that you look for. It answers questions for the prompts, and the contents are kind of more exciting because it's about writing an essay, a blog post. I'm sure all of us have done that, in which we're asked to do some writing, right? And then we would say, oh, it's too hard to write. Let's ask, for me, I like to use Claude, Anthropic Claude. I find it writing pretty good, yeah, among other, choices. So things like that. So that's GPT. And then actually this one, again, some history too. GPT actually came out in 2018. First of all, there's a paper from Alec Redford's paper on OpenAI's website, and it's kind of set the stage, right, for pointing to this direction. Very soon, OpenAI releases in 2019 the GPT-2 language model that incorporate more of the documents and corpora in there too. And then very soon, as we can see, once we discover how to do some of these things, and it inspire like Stable Diffusion from Stability AI to develop text-to-image model, that type of stuff. So as we can see right now, there's just a lot of things going on that is happening every day, right, as we find out. Okay, so now NLP2, let's take a real quick look, just to quick understanding. Essentially, it is an interdisciplinary subfield of linguistics of computer science, and the concern is to be able to process natural language data sets, right, such as like text corpora, speech corpora, and now there's audio, all of these kind of different type of data that it has, right? It uses like rule-based or probabilistic machine learning approaches, and then it enables the computer to learn from the contents, and not only that, it be able to generate, help you to generate a richer context, as we can see, right? That's why it is able to write, very nice essays that better than we can do normally, right, under time pressure, for example. Okay, so that's that. And then now it gets to LLMs, and that's what, as developers, we work with, right? It's a type of machine learning or deep learning model. It's also what is called foundational model. Like in general, all of these are general purpose ones. But the thing is, again, the drawback is that it costs a lot of money to produce, right? It takes a lot of GPUs to do it. But essentially, too, LLMs, if you kind of look at it, essentially it has language processing capability that utilizes NLP, and visual comprehension for the computer vision type of processing, and code generation. And also one thing it's kind of above, kind of big value added is the human-centered engagement too. It can kind of answer prompts like a human, analyze the sentiments, and generate a richer set of output for us too. Okay, so this kind of, again, put this into pictorial concept, is that LLMs is kind of fits into the deep learning kind of core of this whole thing, and it deals with transformers, and then there are also image generation too on the other side, but it makes use of like NLP and also data science behind it. So if we want to kind of put all of these terminologies kind of all in their own perspective too. So, and this actually, I took it from Google Cloud. I thought it explains it quite well in here. Okay, so how do we work with LLMs, right? So, well, these are like non-Java based. If you're a non-Java programmer, then I'm sure some of you are already working with LangChain, Llama Index, and I apologize somehow. I think on this big screen, it seems like I didn't check this slide, but it's kind of a little bit off. So anyway, but you can see too, there's semantic kernel from Microsoft. And again, these are like open source too. It doesn't cost you anything to use it. It's just to leverage on development. Gemini API, again, working with Google platform would be good. And also Hugging Face, which is think of it like a GitHub for AI kind of resources. You can have models, sharing models, or data sets, or even like their playground, so to speak. So it's a great place to kind of get an account and try different models too. And then there are also Java. There are also Java-based API frameworks. I just wanted to share if you are Java developers. There's LangChain 4J. I think that one, they started off more like mimicking what LangChain has. And LangChain, again, is Python and also TypeScript too. But LangChain 4J is Java-based. And also Semantic Kernel from Microsoft also has a Java SDK to it too. And then, of course, if you're a Spring person, then Spring also is coming out too with Spring AI earlier this year. And it is still being developed. It can integrate well too with, for example, LangChain 4J. And then wanted to point out this JLlama is a Llama port, a Java port for working with Llama and other models too. And this actually came out of DataStax where I worked at before. The chief architect did that by Jake. And so also another library called JVector, and it works with Project Panama. If you're a Java person, it basically helps too with improving the speed of vector API searches. So that's that. I can summarize that. And plus, at the previous company, it was a company that works with Apache Cassandra. So if you're into that, that's what it's primarily supporting. But I think the technical founder, Jonathan, will be working on trying to work with supporting other vector database. And then there's also Llama 2, which is a port from Llama C. Okay, so this is just a quick kind of example, LangChain 4J, if you're not familiar with, but I won't spend as much time. But essentially, too, anything usually, too, when you work with models, you want to also make sure you have open AI API key to work with. In this particular case, it's just a simple blind, like generate some text, but it's not actually not doing anything beyond that. Again, it's just a hello world example. Okay, so about people players too, as I kind of mentioned, there are data scientists and computer vision engineers. They are the subject matter expert, but data and AI engineer and ML ops, these are newer type of roles that we as developers, engineers, we can expect to have too. That, we will have not just coding skills or software engineering skills, but we also understand data better and applying, our AI techniques to it too. Okay, so now let me get into the data and streaming and GenAI aspect of it. I find that it is, well, as such, I worked with Apache Pulsar previously when I was at DataSec, so I pay more attention, and also working with reactive systems. I've been thinking too, actually, with AI and machine learning, we can explore further into leveraging the techniques that we learn from event streaming, especially if you work with event streaming, for example, like Kafka, right, and that type of approach. Because here we are talking about huge data sets, and then data that's kind of moved from one boundary to another boundary. So essentially, we're talking about using data pipelines to move data around, right, in different kind of stages of the processing. And another thing too with streaming is that the capability is that it also helps with doing asynchronous type of continuous processing. Asynchronous meaning that it's no more just like blocking kind of calls. So you can be having data that comes in and you immediately process it. So it brings in that real-time aspect of it. So kind of, again, if you think like Kafka, or thinking like other technology before Kafka too, that can be like messaging systems, for example, that we can actually bring into processing AI and machine learning type of applications too. So, and the thing is too, is that I'm looking at, right, generative AI streaming type of usages on a high level. I guess we can think of input, right? They're coming from prompts. Could we actually have prompts be kind of, we receive prompts on a dynamic basis, right? It actually can be done too if you have multiple prompts. For example, you're doing multiple agents, like leveraging on an agentic approach, Different agents are doing different things, but it also sending prompts into some LLMs, and each agent can be interacting with different LLMs, for example. So maybe that's where we can put in this type of, leveraging on like event streaming type of approaches to do prompts. And also intermediary steps too from LLMs. LLMs could come back with answers at any time. Maybe we can have a Kafka topic, something to receive the responses and then process it accordingly. But I don't think there are actual examples out there yet. But I like to think that we should be able to use event streaming to kind of, help with like LLM kind of processing usages too. And so that's just what I'm thinking, right? GenAI streaming kind of usages. So now, let me then also take a look too into RAG, and some of you have, I guess a few of you have worked with. It stands for Retrieval Augmented Generation. And so it is a hybrid framework that integrates two components of the RAG model. One is the retrieval, the other is the generative model. So conceptually, it's not way too complicated, right? One is just takes care of retrieving, and the other is to generate the responses. So let's kind of take a look, right? So retrieval is basically, think of it like a librarian. So now, it goes back to what I talked about earlier. LLM is limited. It actually, it doesn't have memory by itself, right? And also, not only that, you are talking about some general purpose foundational model. So it doesn't have data that's such as, you are working for a law firm, or you're working for a health industry, health care kind of organization, insurance company. You have specific data that's not in whatever it is out there in the LLM. So what do you do with it, right? And so not only that too, and what about, LLM is usually trained, right? It takes so long to train, so you don't do it too frequently. So then it has data that's usually old, right? Kind of, for example, even ChatGPT 3.5 that came out in November of 2022, it only processed data up to 2021 because it just took a long time to produce that ChatGPT 3.5. So what do you do with the time? The time keeps going on, data keeps going. It isn't waiting for you. We're just using computers as kind of some kind of artifact. We take data up to a certain time. So we have to deal with that data that keeps running like that. So essentially, you can use a retrieval model to help with it. So you can actually pull in relevant information. For example, your company, you have legal firm or hospital, all of these things, insurance company, then you have your own private database. You can actually set up, right, a retrieval model to essentially pull data from your life database. And also, too, you can be processing that and keep that within your processing, your operational boundary, so then it's not exposed to the outside world. So that's kind of an advantage of having a RAG in your private space too. So from a database, and then I talk about also event streaming, and what about, you could be also doing, gathering information, for example, like auto collision company, some accident happened, there are data that comes right in. It could be a Kafka topic that's receiving some information, a crash report, something like that. So you could set up like a topic to receive certain data that you can process it right away. Things like that, right? So you can kind of set up a RAG model essentially to pull data from any external sources. So those are just some examples. It can also be even like, I worked for some trading firm before in Chicago that we have actually price quote, right, for some futures and options, price quote for some financial instruments, let's say even stocks. So it probably will send it, like some companies that are, they call price maker, right, to generate some prices for trading. So they send it to us through a socket, things like that. So you could actually set up a RAG to kind of receive those data in a socket as well. So those are kind of examples of what you can do with a retrieval model that pull in data from outside of what the LLM knows. And then from there, of course, you have to clean all the data and all stuff. And then from there, you do searches, and basically you can construct prompt and then send it further to the LLM for further processing too. So kind of multi-steps within this RAG pipeline. And then at the end too is that you feed it all the data to the LLM, and it will process it. It does all the search, whatever prompt you send it to it, and then it generates some results. And the generative model would then take the results and act as the writer, and then crafting up all of these responses and adding in more color to the data, making it more, contextually rich, essentially. So that's kind of like the RAG, in a few minutes to explain. That's what it is. Again, role of the generative model. Generative side will synthesize the retrieved information into coherent and contextually relevant text. And then it built upon LLMs too, and then it creates, text that is supposed to be like grammatically correct. Usually it is, I should say, meaningful and aligned with the initial query and prompt too. So essentially, if you kind of look at it too, the RAG framework is that the retrieval and generative side, they work in tandem to produce the answers that you want. So, okay, so that was that. And really quickly too, I know. We talk about event streaming, but let's also kind of touch a bit too on vector database, because I've worked a bit with it, and I think it's kind of closely tie in to this generative AI time frame too. So vector database, so what it is, right? And also too, I wanted to bring this in because RAG very often too also leverage on vector database to help with storing the data. So as such, right, as we all know, LLM doesn't have memory, and you can actually write RAG and use an in-memory model, for example, but it's probably easier if you, not easier so much as it is kind of makes more sense. Let's say you are designing a chatbot. It's not very fancy anymore. Chatbot, everybody does that. But the thing is though, what about, you're chatting, you want to keep, especially, let's say you're a CRM, customer relationship management systems, you want to save all of the chat history, things like that. So you may want to leverage on a vector database to help you with that. And why do you need it? Because essentially too, as such, right, GenAI, we're talking about multi-dimensional data that's contain a lot of information that allows you, all to search for it and build, essentially the storage of data that actually is contextually rich. So it's essentially what is called multidimensional. Because, well, anyway, let me kind of go into it. So, okay, so what it is, vector database is that it supports like a vector data type, right, for these complex machine learning purposes. And so how it is doing it is that now instead of storing data as is, maybe now we actually need to store like a strings of data in it, right? There, there can be many variations of it. So in other words, let's say you take a string, right? Because these are multi-dimensional data, then you have to translate it to a form that you can store it. So that's what it is, using what is called vector embeddings. Embeddings are essentially numerical representations of the data. So this data is not just like one thing, cat or dog or something. It could be like some strings that talk about, cats or talk about dogs. I'm just using some example. So then you need to store that into your vector database, and then using this vector type as numerical representations. And if you look into it, a vector database is always an array of floating point numbers that represents it. So it gets quite complex, as you can see, right? So it's a way of what is called machine learning, is feature engineering. And also too, interestingly, with this vector database, it makes use of this nearest neighbor algorithms to do all of the searches. So if you are math inclined, that's linear algebra. All of your matrix operations, that's what is being done, on your database to do it. So just share a bit with you. I found it fascinating. So, you may be wondering, how is it being done? So just quick kind of describe it. If we use a two-dimensional vector, kind of to look into it. So let's say the V1 is your search string. It could go here. So it's represented in a two-dimensional space as like a magnitude and a direction. But let's say, right, V2 and V3, the red ones, they are already stored, data that you have stored into a vector database. So when you come in and you're searching for V1, V1 is over there. So it uses this nearest neighbor approximate nearest neighbor algorithms. Then it will kind of return you V1 is the closest, or actually I should say V2 will be returned as the closest to V1. So let's kind of take a look at another example, a bit more practical. again, a very simple type of hello world example, two-dimensional. It could be you searching for cat inside this vector data store, and the dog will be returned because it's categorized as a animal, for example. Again, this is just a simple kind of way of explaining that. But as you can see, again, right, these are complex things is trying to explain it easier. But in reality, too, as we know, right, we talk about things, the same meaning can be expressed in so many different sentences. So in order to kind of deal with this complex language feature, right, it's going to do searches using linear algebra, and it does things in different layers too. And then essentially that's what it is doing. So, and again, really quickly kind of explain to you. And then there are vector data store if you're interested. These are open source. PG Vector, for example, I've actually done a workshop on that, and it's extension of Postgres if you're interested in that. I find it to be easier to work with, and it's open source. These are all open source anyway. Then there's also Milvus, Chroma, Fast from Meta, and then Quadrant and Weaviate. They seems to be kind of quite popular open source vector database. And then vector embeddings, what are they being used for, right? They are, besides searches, you can use it for clustering, recommendations, anomaly detection, diversity measurement, and classification too. So that has kind of multiple kind of usages to it too. And also, one thing to kind of point out, if you are using vector, you need to store them. You need to use some open or embedding specification. OpenAI has a set of them too, and there are other organizations. But make sure that when you store them, you're using one model, then use the same spec for doing query too. Otherwise, you won't get the same results. So that's something to point out. And then also, one thing to point out, you can use traditional database for AI type of processing for this, but it probably would take you more time, and it's also requiring more work on your side to deal with this multi-dimensional data. So that's why we may want to consider using a vector database for your generative AI type of usages, building racks. And this is kind of an example too of how you would how you position this vector database within your RAG type of application. You can see it's helped to augment all of the data from your LLM, and then also allows you, to kind of service your results and send responses too. So yeah, again, just a quick example to show you. Okay, so now it gets into agents and workflows. Just wanted to kind of point out, well, as we can see, right, LLMs are kind of restrictive, and it's as powerful as it might have seen. And just a lot of things it's not able to do yet. And I always think of the current GenAI revolution. We're at the stage of, it's like we first, the humankind, we first invented airplanes, right? That was in the US. The Wright brothers, from Ohio, although they did it in Georgia, was they fly the airplane. But at that time, the airplanes cannot fly over the Atlantic Ocean. I mean, not to even say, right? It can't fly too far, only like 2 people. So it's kind of like that right now. I think it's as exciting as it is. The thing is, too, is that we have to do a lot more to make it actually scalable, secure, and actually able to maybe perhaps use it to generate a flight reservation, for example, right? So it will take time. It's like airplanes, we need all the aerodynamics, all of these principles. So I think we're in this revolution of discovering new things. So I believe that AI agents probably is the right direction to go. And also, I get this, I was happy when I first learned about it from deeplearning.ai, this organization by Dr. Andrew Ng. He's like a famous AI specialist, right? Also business entrepreneur based in California too. So I really like his stuff. And so he brought up the AI agents. He believes it would be the way to go, like especially if you are going to do enterprise type of apps. So just wanted to kind of point out, right, agents, right, what it is, right? Within the software context, actually agents is not all new. If you have been working with software development for a while, if you kind of search for it, there are always agents doing something. Even like, in your Linux, right, you actually have to do some agents to do instrumentation. So that's kind of like the same concept, right, in which agents will execute some code on your behalf. And so they are software entities. And then within this GenAI context, it orchestrates complex workflows for you. And it not only that, it coordinates activities of multiple agents and does all the logic, all of these things. So, and it's not really too good to be true. So However, in the Gen AI context is that there are multiple patterns that we can be aware of. For example, reflection. So you can think of LLMs. You are going to, well, let's put it that way. Normally, too, if we are using LLM as a consumer, we just do a one-shot or zero-shot type of prompt. You're asking a question, type of a question, and LLM will just answer it. And then you don't actually go back and tell LLM, well, it is wrong, and then you need to refine it. So that's the thing. Reflection is an automated way to enable us to ask the LLM to evaluate its first answer. And then saying that, okay, in other words, right, let's say if I'm asking LLM to look for something for me, then it comes back with some answer. And then I'd say, well, it's not very good, this answer. Can you, LLM, can you look at it, you made some problem. Can you evaluate and come back with a better answer? And very often, actually, LLM will be able to do that too, and comes back eventually. You do several iterations, and then it will get better. So the idea of using agents, this agentic approach, is to automate this kind of repetitive, taking answers and feed it back and ask the LLM to do multiple iterations to give you better answers at the end. And then another pattern is the tool use. So let's say, right, sometimes too, LLM may not know the answer. And so, in other words, you can set it up so then you can tell the LLM to say, go search the web or search some URL, specific site. If you can't find the answer, go search for there. It's like a backup way telling LLM another way out to search for answers for me. And you can tell it to look up Wikipedia, for example, things like that. So it's kind of a tool use type of design pattern. You can do it. And then also, too, these two actually, based on Dr. Ng's research, he said the reflection and tool use, they have done a lot of statistical searches or research. They found out that they are pretty accurate. It gives you answers that are more accurate. But then whereas if you get into planning, so planning is, again, you're also using agentic approach, and then now you are asking the LLM to, actually, you won't tell it exactly what to do, but maybe you can say, I have this task to do, can you go plan it? So you basically are asking LLM to set up that multi-step approach. Let's say, right, I can just say, well, go do some research on this subject matter. In general, too, you may you break it down and say, okay, go then do research on a subtopic, and then gather all of your results, and then write an initial report and generate the results, something like that. But instead of you planning the steps, you are asking the LLM to do the planning for me. So that's what its planning means, right? But the thing is, too, according to Dr. Ng, is that it is so new. I think it's not very accurate yet at this point, but they believe that eventually the LLM should get sophisticated enough and be able to plan out things better, so then it maybe frees us up for not even think of what steps should be needed, right, for doing a research paper, as an example. So that's the planning. And then lastly is the multi-agent collaboration, and this one is basically, if you think of like doing agents, well, think of agents that way. It's like, some of us are maybe in consulting firms, and we know that when we do a project, right, think of these agents as sort of mimicking human beings. So you can have, usually to an IT project, you have software engineer to do development, you have QA engineer doing testing, DevOps engineer to do deployment, and whatever it is, right, and delivery. And then you have a project manager too. So multi-agent should be there to tie together all of these different agents. Whatever they're doing, they should all come together and produce something that's orchestrated real well. So think of an agent as an orchestrator to orchestrate all of these processing by different agents. Each agent is specific to certain tasks. That's what it is. So yeah, and then let's see. Is it possible if I switch to my and switch to my thing? So I'll just show. Yeah, okay, so there's one Crew AI, if you have looked into it, is a library to enable you, newer to do multi-agentic type of design. So this one I thought is good because it illustrates too. Essentially too, if you look at AI agents, they each have certain specific tasks that is assigned to doing. But they each too can also be reaching out to each other and ask questions too. So that's the thing. Think of agents as more autonomous in that sense. And then essentially too, then there's also a process. It's defining how the agents will work together, how the tasks are being assigned and it interacts with each other, and see how they perform all of the work. And then there are actually specific tasks that resulted from this whole kind of design too. So tasks can actually also override agent too, and to kind of decide what to do. So think of a consulting firm is basically too, you can have maybe like, practice lead to decide what to do, and then it goes through maybe the team lead and assign different tasks, for different functional areas to do too. So think of kind of agents is more like mimicking how the human beings, we work on projects, things like that too. And then also, another thing, the fourth one I wanted to show is the multi-agentic collaboration. This one is kind of interesting, again, from Dr. Ng's example. This one is actually come from ChatDev. There's like an illustrative purpose of like a prototype that's built called to illustrate multi-agent collaboration. So again, right, you have different, kind of phase of doing designing in an IT project, they're designing and coding, testing, documenting. And so each one of them too can kind of go through all of these. And so think of like this multi-agentic approach is automating way of kind of doing like a whole project development. And that's what it is. So just again, just wanted to kind of share with you about this too. So that's what kind of multi-agentic is.
Do you want to put
I can kind of go in here
the
too. So examples too, I think I'm kind of almost out of time. So examples of a few multi-agentic libraries. Just now I show is Crew AI, and I find it interesting because Crew AI will kind of have this concept of a role playing. You can have different, so it requires you to design your system to understand what your system should do, and then assign and design different agents to it too. So I find it to be quite interesting. I think the better ones among the other that I look at, for example, like AutoGPT or AutoGen, those are kind of, AutoGen comes from Microsoft, by the way. They're also good too, but it's just, Crew AI has a better concept of the role playing in there. It's what I'm finding. And then there's actually also LangGraph. I haven't actually tried yet. Maybe some of you have. So just wanted to share with you some of these libraries that you can think of doing. Okay, so now I think because my time is short, so let me then move on to the last part, which is challenges, right? We look into all of these, kind of thing of what you call like GenAI. It seems kind of exciting, but be aware of hallucinations, as we all know. Hallucinations. I just want to point out one thing is kind of interesting. I thought I'd share because I'm involved with AI Camp, a lot of user community, and somebody kind of brought out this really interesting case of hallucinations. So somebody asked ChatGPT or whatever LLMs. And describing himself, he was saying that, I'm not happy, I'm depressed because my family is not doing well, my work is bad, my boss is yelling at me, all these things that made him depressed. So he asked LLM, the ChatGPT, is like, what should I do? And then it came back, it says, well, why don't you jump off a bridge, right? So that kind of stuff. So just kind of caution, the LLM, as powerful as it looks, it cannot make any good moral judgment. So we have to be aware of that. I think we are all aware of it now. And then, of course, there are also governments putting in regulations, regulatory stuff that's going on. And also, too, there are no real-time, up-to-date data, but of course, the RAG patterns is what is suggested to help with that side. And then also, LLM usage is just not ready for production. Again, I talk about scalability, security concerns, and also one thing I actually meant to say is also the sustainability aspect. Again, it takes a lot of more energy to do that now. As we know, even with GPUs, it's going to take a lot of time. As much as fancy as it looks, it actually takes a lot of energy and not very green, right, kind of thing. But I think there are a lot of research now to make it better, but I think it would take some time. So just be aware of that too when we are doing GenAI types of apps. So, okay, so now I think comes to the last part of this is resources too. If you are interested, the slide deck can be accessed. Oops, actually. Oh, I think I have to kind of switch back. Thank you. Okay, so this is the bit.ly code or the QR code that you're welcome to scan if you want. Yep. if you miss, don't worry. I'm here the whole day. I can also share it with you too. Okay, and then these are just couple of, if you're interested too, in some of the lab, I thought I'd just share it here too. So if you have scanned that, you'll be able to get to here. Because I did like a PG vector workshop just to work with that, and it was using OpenAI clip model, is text to image kind of searches. It was kind of interesting too. It's like easy to do kind of thing. And then also, if you're in Java, then there are some LangChain 4J examples that I found to be quite helpful, working with Spring Boot and working with RAG. And there are different levels of RAG. You can do easy RAG or advanced with a lot of filtering, all of these things too. So just highlighting a couple of things. There are many examples of integrations too. Okay, and then some interesting too, open source ranking information of vector search engine, I thought I'd share. That's an interesting site. It's just mainly measuring GitHub, open source GitHub stars to see how popular certain open source software is. It's not just for AI, for all kinds of software too. I thought I'd share with you here. And then also, I have a stream. I'm trying to restart it once I get back, kind of calm down. This is my Twitch, if you'd like to follow me there. And also then with that, I wanted to thank you, and this is how you can stay in touch with me. I'm on LinkedIn, on X or Twitter, and then I have my Discord server too. And then also, I have my Chicago Java users group. You're welcome to join, and even we have a live stream, just so you know. So you can watch it later too. We have our YouTube channel. And then I'm also lead, the Chicago chapter lead of AI Camp. So we do a lot of AI stuff too from there. And then with that, I want to thank you for your attention, and thank you so much for Gurtam. And thank you. These are you can tag us. So thank you. Okay. Yeah, I think I have.
All right. We're going to do 10 minutes for Q&A. Who has a question for Mary? Because otherwise, I'm going to go into the Discord. I saw during the chat, there was the same person. I don't know who Kari is, but they had many questions. The first one, what is inference latency optimization, or what inference latency optimization techniques have you used for RAG or agentic models?
That I do have to admit, I haven't done that yet.
Okay.
Yeah. So, but whoever asked the questions, let's connect, because I also would like to know too. To understand deeper your question. Yeah.
Nice.
Yeah. So, okay.
Have you ever tried Grok?
Grok? No, I have not yet. Yeah.
I saw it was missing from the slides.
Oh, yeah. Okay. Yeah. Okay. I'll remember that. Thank you.
And what is your secret sauce for reducing the generative AI costs in general?
Secret sauce. Right now, I think it's not easy, right? We're not so much in control of the LLMs that we use, and once we hand it off to LLMs, it's up to LLMs to search for things. But I think in that case, if we really want to have secret sauce, perhaps we do need to train the model, I think. Yeah, I think we will need to do some training ourselves. But very often, though, I think there are so many aspects, right, of doing GenAI, and we can spend the time training, and then at the same time, then how do we? What makes value is the inference too. Yeah. So I think maybe let's say if I have a big project, I have more people, then somebody can help with training better models that's kind of catered for our own specific use. I would think so. But again, a lot of times too comes back to when we're doing whole project management, then we have to consider the cost, right? So but I do believe if I have all the money, maybe I'll have better models that's more catered for my own use. That's even better. Putting on the weight, the temperature, all of these things, I think. Yeah, that's
Do you think the compute power will then move to devices, like for example my phone instead of a central server for the cost problem?
Yeah, well that's a good question. Yeah, that's true. Everything more like becoming the local. That too. Yeah, then you reduce that network latency as well. Yeah. And also the security concern too. Yeah, that's right. Individual devices too. Yeah, it will be better. Yeah.
What is your opinion on the best solution combinations for natural language processing data clustering in Python or Java cases?
Oh, can you repeat the question again?
What is your opinion on the best solution combinations for NLP data clustering, specifically for Python and Java cases?
Oh, for Python and Java cases. I think, that's a very good question too. But I think, we all know that Python is more powerful or has more libraries for you to enable you to work with large language models and machine learning languages and machine ML AI apps. But Java too, to me, I don't feel Java has reached its potential. It's just that there's just very low interest, right, in this language community to develop more things with machine learning for machine learning type of purposes. But I think, to me, I feel that, well, that's something I've been thinking too, is that if we can leverage on some of those Java powerful capability, more of the back end, I think we need to understand each language's their capabilities and then combine them, right? You should be able to combine the best of all worlds. Like, let's say in this case, Python has all the libraries that does all of the nitty-gritties, but maybe we can leverage on Java with doing like back-end, the scalable type of thing. If we can kind of combine the two, and then of course natural languages too also is very powerful, but usually we deal with data in huge quantity, for example. But maybe if we can combine different the power of each language kind of capability, we should be able to do something like more powerful, essentially. And then you don't waste all the resources from the different capabilities. I think that's what it is. But we haven't been there yet.
Yeah.
But I would be interested to find out if there are ways to do it. And also, for example, like Java, right, is really good with streaming. Now too with virtual threads that comes out, I do believe that maybe we can leverage on virtual threads to help out with all of these processing that are needed in machine learning. But it's just I'm not seeing that yet, or nobody has done yet. Maybe anybody is interested should start looking into it. Java too is kind of very open source base, or at least, right? And then JCP, if you're interested, propose some paper. But I think there are already some projects going on too. I forgot which one. There's some projects started doing to support Java for AI machine learning type of work.
Gotcha.
Too. So yeah.
Interesting.
Yeah.
Did Mary's answers provoke any more questions before I go to the Discord again?
Sure.
Yeah. Let me give you the mic real quick. Go for it, man.
Hello, Mary, and thank you for the presentation. Also, welcome to Vilnius.
Thank you.
Nice to have you here. Compared to you, I'm honestly an amateur, but we touched a very interesting point about local models, or I don't know how we call them. I'm curious to hear what use cases you see in the future for locally hosted models or agents, because right now I used some Olamas models which I can host locally. I use them for development purposes, but I would say 10 times out of 10 they were worse than cloud options. All the suggestions were worse on my machine, and they were slower. So do you think that will change in the future, or maybe the only use case that we will have them on phones with the really fast processors doing the generation, and that will be it? Thank you.
Yeah, that's a very, very good question.
Great question.
It is true. Yeah, it is true. I mean, the thing is with AI, it's supposed to serve us, and we should be able to use it easier, right? They're like, have access to something that's on the network. And that's no doubt is just more powerful because it can hold a lot more stuff. And then local, as the devices are very limited to in resources to hold it. So I don't know. I believe too it's true. I think it's like Patrick mentioned about maybe individual devices we're going to become more powerful that can hold more capacity, right? But I think it's not able to do, we'll not be able to catch up with all the server size type of thing. But I think we'll get better, I believe. Perhaps too, there would be ways of us linking, right, our individual devices and very secure, high secure way of, maybe it's like the VPN that we're doing now with just pure network kind of thing. Maybe some kind of virtual private network that connects, maybe. Yeah, and this is a wild guess, right? That can, we have to think of security too. We are connecting to something, over the wire. And of course, the network capacity needs to also increase too, like what you call the bandwidth needs to be expanded so we can kind of stay connected. Those things, it would take some time, but I do believe what we're seeing now will be increasing, in capacity, capability. For example, NVIDIA is already doing some research to improve speed, right? Things like that. So I think, it comes from all sides, essentially. It is what I feel. Yeah, and it will happen. We will, yeah, it's like when we first have PC, it was 64 byte, right? Very, now it's like, we're like so much more now on our computer. We're like talking about gigabytes of memory on our machine. So I think it will get better. Yeah, it takes time. So.
Yeah.